So now that we have a general idea about, where electrons kind of exist in the electron cloud, let's talk about specific elements. And let's talk about their specific electron cloud. And we're going to show you a notation which allows you to identify where the electrons specifically kind of exist. And again, this is called electron configurations. So let's take an element. Let's take our first element. Let's take hydrogen. Now, hydrogen has an atomic number of 1. And yeah, there's other information about hydrogen which is important, but for electron configurations, assuming it's a neutral atom, I only care about the fact that it's got 1 proton, and therefore, if it's got 1 proton, it should also have 1 electron. Again, if it's neutral, the protons and electrons are going to balance. And that means they have 1 electron. And so the notation goes like this. You have 1 electron. That first electron is going to be in the first energy level. And that first electron, because the first energy level only has an S sublevel, will exist in the S sublevel. So we write this little notation 1s. And what we say is, well, since it's in the 1s, remember the S sublevel can hold up to 2 electrons, up to 2. But I don't need all 2 spots. I only have 1 electron. And so I can put a 1 here. It looks like a power. It looks like a power, but really all that's saying is, look, I got 1 electron in the S sublevel in the first energy level. So it's a weird way of writing like an address for electrons. Now, another way that this is represented for a different reason is the following. We write 1s, and you put a box or a line. Now, I write typically lines. Some other books will put boxes. And what this box is going to represent is the electrons you have in this sublevel. So the S sublevel, I have 1 electron in that sublevel. So I'm going to represent that electron in this box or on this line in a minute. Now, again, this 1 outside here, this big one, tells me, hey, this is all going on in the first energy level. And we always write the lower energy levels first. We always start with number 1, and then if the atom were bigger, we write energy level 2, energy level 3, and so forth. So we have this 1 electron. And what we're going to do is represent that electron as an up arrow. Up arrow. There's a reason for that. I'm going to hold off on the reason when I do the next example. Okay? So this is 2 versions of how we represent the electrons in what we call electron configuration. This little box or line, and again, sometimes you'll see this as a line, not just a box, has a special name. But I'm not going to give that up just yet. I'm going to tell you in a couple minutes what this is. Now, that would be hydrogen. Let's go to helium. Helium, if you go to helium, has 2 electrons. And it would be very similar. The first energy level, that's where we start, lowest energy level, okay? And it's got an S sublevel, so that can hold up to 2 electrons. Well, hey, I only have 2 electrons, so both of them can fit in there. Now, that's not a squared, although it kind of, for math class, it looks like a square. It's not. It's a weird notation. Again, chemists use it. It says, hey, there are 2 S electrons in the first major energy level. And if we write that with the box or the line representing those electrons, again, a box or a line. Now, the one sheet I'm going to start you off with is boxes, but you're going to find out I generally tend to go to lines later. And I want to write those 2 electrons in here. Well, I told you it was an arrow, right? An arrow represents an electron. So a lot of students are going to be like, oh, well, I got 2 electrons. 1, 2. And that is not right. That's wrong. That's wrong. When we represent these electrons in these little boxes, we have to have electrons point in opposite directions. This box or line represents what we call an orbital. An orbital is a region around the electron cloud that holds these specific electrons, where electrons exist kind of paired. Again, the nuclear physics as to why this happens, we're not going to get into. But all you need to know is that, hey, if I have a upward spin of an electron in the same little orbital, I better, if there's a pair of electrons, that paired electron, the paired electron better have a downward spin. This is a bit of a lie, but think about it this way. If I spin something, I can spin it this way, or I can spin it in the reverse way. There's two ways to spin it. And all this is saying is that if two electrons kind of coexist together in the same place, one has to spin one way and one has to spin the other way, so it can be balanced. Now again, as we saw in hydrogen, sometimes you're not paired. Sometimes you're solo, and that's okay. The electron is going to be solo. Typically, if the electron is solo, we always start off with the upward spin, the upward arrow. It's kind of arbitrary, but that's what we do in the general notation. So we have the orbital notation, got the abbreviated notation here. Note, this is a little easier to draw and write because all you have to do is a little power. You don't have to think about what's going on with the orbital.